white. The cameras on board the meteorological satellites, like goes east and goes west, those cameras are not in color. Those are black and white cameras. It has to do with the fact that what they're looking for, clouds, are kind of bright white. Realistically, being able to tell the difference between different shades of white is more important than being able to tell, oh, look how pretty brown the United States is and how pretty blue the ocean. When you go see something like this on a website or on TV, it is fake, 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 fake. Some sad intern colored this. Okay? Probably not by hand. Generally speaking, the way it works is some computer program takes the first stab at it and then they kind of touch it up. Okay? Okay, not literally color like with crayons, by the way, but whatever. Fake, 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 fake. They took a real picture and they colorized it. Same with like this. Fake, fake, fake. Oh, wouldn't it be lovely if our satellite... Don't get me wrong. We have satellites that can do things like monitor the color of crops and so on. But this is just fake. Okay? This is not what's going on here. This is just, they took a real satellite picture and then they used a computer program to color in the land. On board the satellite, there's actually two types of cameras, or two types of imagers that are taking pictures. One type of imager, and by the way, this can be either on geostationary or on polar orbiting. Geostationary or polar orbiting refers to the platform. Then they can mount instruments onto the platform, right? There can be visible cameras and there can be infrared cameras. We don't usually use the word camera, we usually use the word sensor or whatever. Visible images show what your digital camera shows. They show light. They are taking pictures of reflected shortwave radiation, sunlight. They are pretty much what you would see with your little eye if you were up there on board the satellite. Except, of course, it's in black and white. It's pretty much what any astronaut would see. And it has all the pros and cons of that. For example, like in this globe picture here, again, I apologize, this projector has problems with black and red. Here's the United States, here's the Caribbean, here's Europe, here's the Atlantic. It's not like there's no clouds here over the United States. It's because the sun hasn't come up yet. Okay? If you can't see the clouds, you can't see the clouds. Right? These visible satellite pictures, which are what you probably thought those cameras were taking pictures of, are, well, they are, let me just jump over here. They are what you think they would be. I mean, they're pretty much just a picture. There are certain features, by the way, that you can see on visible satellite pictures. One is what we call the terminator. The terminator is the boundary between the half of the globe that is lit up by the sun and the half of the globe that isn't lit up. And again, on your computer, you'll see this better, where like it's pretty obvious that it's just dark here, and from here over this way, you'll be able to see that like there's a terminator between the two sides, with it lit, this being the lit half side of the globe and this being the unlit side. And you can usually see it quite clearly, actually, on a satellite picture. Visible satellite pictures, you can also see things like shadows. I mean, if one cloud is higher than another cloud and it's casting a shadow on there, you have no problem seeing that on a visible picture. Like, here's some shadows. And I think there are some other ones, examples on the website that I'll move to running a few minutes late. The other thing about visible satellite pictures is they have very high resolution. Here's a visible satellite picture off the coast of Florida. So here's Florida. Again, I apologize, it's got a red map on here, so you can't really tell the difference. Here's Georgia, here's South Carolina. These are individual little cumulus clouds you're seeing here. And actually, I mean, we have even satellites. This picture is actually, I got it, what does it say, 2001, I think. I just got this off of a template. So I mean, if I got a new picture that was taken today, it's even higher resolution. You might even be able to see the difference between what's going on the north side of the cloud versus the south side of the cloud. These are pretty high resolution pictures. When we come and see examples of infrared pictures, we'll see that they're not nearly that good. Infrared pictures are kind of like heat pictures. You see those pictures of like a house where they use heat sensing. I think I have some examples for that. Let's see if they... No, I did, I don't. Where they're really measuring heat. Like you see a picture of a house and it shows you that the windows are leaking heat and the doors are leaking heat. That's what the infrared pictures really are. They're really measuring temperature. Well, no, what they're really measuring is long-wave radiation. But way back in the first unit of the course, we learned about how long-wave radiation, I mean, by Stephen Boltzmann's law, the warmer an object is, the more radiation it gives off. The cooler an object is, the less radiation. So by measuring the amount of radiation the clouds are giving off, what we really can figure out is how their temperature is. And based on their temperature, we can really figure out how high they are. Higher clouds are colder, lower clouds are warmer. So when we're looking at infrared pictures, what we're really looking at is how high the clouds are. Well, what we're really looking at is the radiation given off by those clouds, which is really the temperature, but that's really telling us how high the clouds are. On these infrared or IR images, the high clouds, by convention, are colored in brighter shades of white. So if they're colder, we color them in bright white, and if they are warmer, we color them in darker shades all the way down to black. And so if you look at an infrared satellite picture, it looks something like this. Here's the United States, and here's an infrared satellite picture. And we can see that there's all this cold stuff, which apparently is high clouds. And then there's warm stuff, which is probably either very low clouds or the ground. And then there's more high clouds. The nice advantage of infrared is that it works day or night. Clouds are emitting radiation day or night. It doesn't matter if the sun is up or not. So like this is a visible picture over here on the left. It's damn near useless because it's dark. Right? On the other hand, infrared has no trouble seeing the clouds. Okay, these clouds that are over here are emitting radiation. They're telling us that they are colder and higher. These places maybe are warmer clouds, whatever. So if you compare these two images side by side, you can see that they are, the infrared has the advantage of working day or night. Oops, that slide should not be in there. The other thing though about these infrared images is they don't have very high resolution. I mean, if I flip back, say, to this diagram right here, this example, I don't think we're seeing each individual cloud here. Right? Realistically, we're just sort of seeing that over Arkansas, there's generally high clouds. And they're cold. And over eastern Oklahoma, because it's a grayer color, these are clouds that are apparently lower, but we're not seeing each individual cloud. Right? These pictures just don't have that fine of resolution. They are not like the visible pictures that have such detailed resolution. Now we're going to be using satellite pictures throughout the rest of the semester to be telling us more about things like fronts and cyclones and thunderstorms and hurricanes and God knows what. But this way we had kind of an introduction to the tools and terminology. This PowerPoint, of course, is available to you on the Blue Line website if you want to download it, print it, study it, whatever. And we'll call that a day. And on Tuesday we will wrap up with general circulation. And I think we'll start moving on to air masses on Tuesday. All right. Have a good day. There will be a homework set posted later today onto the website. You'll get an email when it's available. Let's see if this works. Hi. You need to get through?
Sorry, I had a question for you.
You have a question for me? Okay. Can I? Oh, what the grade was? Yeah, you can certainly take it if you want. Need a few extra days because you had that. Yeah, no. I'm not. I don't actually see tonight at about 5. At 5, you'll just have your grade. Okay. Otherwise, we'll have to send it. No, I'll you're going to come to see me in my office, and I'll either have them air or Alright. Okay, I need to like email so I have in writing who was there and who wasn't there. Yeah. Yeah, if you want to hold on, do you need to be in class like the next 15 minutes? Yeah. Okay.
We'll have to see Stephanie Ludwig later this afternoon.
You want to just stop by then?
Yeah.
Okay, in fact, I'll give her the notes.
Okay.
Okay, so she'll have them. Because if I'm in class or something like that,
All right. Yep, I should be. I get a class about 1:45, so I probably head to you right after that.
Perfect. That'll work just fine.
All right. Enjoy your day, Professor.
Thank you.